everybody. Good morning. In the last class, we have completed the compressibility definition and understanding with the sketches. Just entered into water hammer. Compressibility is nothing but the reciprocal of bulk modulus of elasticity, which is denoted by K with unit Newton per meter squared or Pascal or kilonewton per meter squared, kilopascal, where bulk modulus of elasticity K is given by change in pressure or increase of pressure divided by change in volume to the original volume. That minus sign indicates volume decreases as the pressure increases. Now we will see in detail about water hammer in pipes or hammer blow in pipes. As I had already pointed out in the last class, that whenever you enter into the bathroom or kitchen, when you stop the valve, suddenly you might have heard some noise in the form of dug dug noise. That is because of the phenomenon of water hammer. Actually, here water is assumed as compressible, because of which the elastic forces of fluid, that is water, which is flowing through pipe, should also be taken into account. This phenomena is known as water hammer. But water hammer can be defined as whenever the water is flowing through the pipeline, if the valve is suddenly closed, then what happens? The kinetic energy or momentum will be transferred into or changed into pressure energy. Because of this development of pressure in the pipeline due to sudden closure of the valve, positive and negative pressure waves are developed, are created, are produced, and they will move to and fro in the pipeline. That means backward and forward till they get damped due to friction of walls of the pipe. During this movement of these waves, there will be a noise produced in the pipeline that is known as knocking. 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 You must have experienced in daily practice. In a long pipe, when the flowing water is suddenly brought to rest by closing the valve or by any small similar cause, there will be a sudden rise in pressure due to the momentum of water being destroyed. That's what kinetic energy will be transferred or changed into pressure energy. A pressure wave is transmitted along the pipe. A sudden rise in pressure has the effect of hammering action on the walls of the pipe. This phenomenon of sudden rise in pressure above or below the normal pressure due to the sudden closure of valve is known as water hammer or hammer blow. Now, you should not be under confusion that since the name is given water hammer, this hammer blow is only with respect to water is not true. It could happen in case of any liquids, oils, other types of liquid apart from water, also water hammer when they are flowing in the pipeline. The pressure developed in the pipeline due to water hammer mainly depends on the speed at which the valve is closed, whether slow or rapid, that means gradual or rapid. Means gradual means slow, rapid means sudden. The velocity of flow of liquid in the pipe, the length of the pipe, and the elastic properties of the pipe material, and as well that of the flowing fluid. Here we normally consider water only, not other liquids. Okay. The rise in pressure in some cases may be so large that the pipe may even burst. and therefore it is essential to take into account this pressure rise in the design of pipes. And also another effect of water hammer is, if the pressure reduces to very low, then there will be problem of cavitation in pipe. That means the pressure should not be raised to a higher value nor to a too lower value. In both the cases, there will be damage to the pipe. Bursting of the pipe if pressure is increased too much. If the pressure comes below normal pressure to the lower extent, then there will be cavitation problem. That's why superior quality of steel material should be used when we are using it for pipeline, so that cavitation can be avoided. Cavitation will take place, but it can be avoided. Further, water hammer, we have to find the expression for rise in the pressure head. We consider two cases: gradual closure of the valve, sudden closure of the valve. Under sudden closure of the valve, we have to consider again two cases, that is, when the water is flowing through rigid pipe, and another case when the water is flowing through elastic pipe. Consider a long pipeline carrying liquid and provided with a valve which is closed gradually. Figure says, let h be the head above the center line of the pipe, let v be the velocity of water which is flowing through this pipe length, L. L is the length of the pipe, v is the velocity of flow water. T is equal to time required to close the valve in seconds, and small p intensity of pressure wave produced. The mass of liquid contained in the pipe is rho Al, where rho is density of or mass density of fluid, that is water, A area of pipe, L is length of pipe. Assuming that the rate of closure of the valve is so adjusted that the liquid column in the pipe is brought to rest with a uniform retardation from an initial velocity of V to 0 in time t seconds. Then retardation of water is equal to V minus 0 divided by T, that is equal to V by T. The axial force available for producing retardation is equal to mass into retardation, rho Al multiplied by V by T. Also, force due to pressure wave is P into A. We can assume P is the rise in pressure due to water hammer, A is cross-sectional area of the pipe. Then we can equate these two forces. Rho Al V by T must be equal to P multiplied by A. Thereby we get the value of P is equal to rho L V by T. Head of pressure H is equal to, we know, P by W, where W is specific weight of water. So rho L V divided by W into T, or in many books gamma is used instead of W. Gamma is used, both are one and the same. Rho LV by rho GT, rho get cancelled away, LV by GT. Because here gamma is equal to rho G. Therefore, gamma is equal to rho G. That's why we get this equation LV by GT. H is equal to LV by GT. The closure of valve is said to be gradual when T is greater than 2L by C. For this particular aspect, we will come across little bit later. The closure valve is said to be instantaneous when T is less than 2L by C. This will come at the end of the class, end of the water hammer class. Let us stop here. Thank you for watching.